Thank you very much. So I know we have a few students in the room, so I thought I would start with a bit of how I got into this industry and kind of what we're working on. So my background is in engineering, as most of ours is. Slight tweak from that, I actually studied games and interactive entertainment at university. I somehow ended up working at a research institution called the Institute of Health and Biomedical Innovation. It's in Australia. I am Australian as well. And I ended up helping them figure out a technique to help map early markers in diabetes. So we actually had this camera that had a 500 times magnification, and we were looking at the back of the eye, and there's a nerve plexus in the eye. And it turns out that if you have diabetes, the nerve plexus breaks down. But they didn't have an easy way to kind of figure out how to map that scene out. So I helped them come up with a technique to do that, and I helped them co-author a paper on that, which is completely random and completely aside to security, of course. And then the next thing I did was I built out an interactive entertainment platform for people with intellectual disabilities for a group in Australia there, and I got some government funding and a few other things. And we ended up commercializing this technology. It was very well received. And we actually built out a system. It's like a 3x2 meter floor surface. And we had a projected screen on it. And then we would use these cameras. And these cameras were built by a company called PrimeSense. So what they are is they're depth sensing cameras. So effectively, they shoot out an IR grid, and then that information gets reflected back to the computer, and you can use that to figure out a whole bunch of stuff. The company PrimeSense, about 6 months into us working on this project, was acquired by a company called Apple. And that technology is now the exact camera that is used in the iPhone X. So the technology there was also used in the first Xbox Connect. So the company that was bought was actually the first Xbox Connect. Then Xbox One came out, and Microsoft actually had to re-engineer the depth sensing technology without infringing on all the patents that now Apple owned, of course. And I have a video of what that technology looks like. So as these kids are moving, what I actually designed was the ability to determine how far away they were from the camera and how high they were off the ground. And this had unlimited touch. There was no concept of multi-touch or limitations. And we had a patent and a few other things on this technology. And effectively, there was 20-something educational games that we came up with. This is kind of the concept of dodgeball, but dodge the bomb. And if you step on a bomb, well, it explodes. And there's like a Pong type style game. And this is all just simply using 2 of those cameras in an array, looking at different signals from the machine. So I've learned quite a lot about image recognition and machine identification from this. And this is kind of like it's that game where anyway, I digress. So back to security. So my topic is talking about airfares. So there's, obviously we all fly. I've lived in Australia for most of my life until recently moving to San Francisco. And, oh no, there goes my leg. That's not a good sign. It's an omen. And there's a bit of an issue in this industry. So this isn't exactly what flying looks like when I fly anymore. It used to look like this. Nowadays, the kind of golden age or the golden era of flying like this, it's kind of gone, right? There's super tight margins now, so we end up paying more, and we end up getting a lot less. I know that my flights are very crammed comparatively, and profit margins are super thin, so they have to do everything in their power to kind of ram in as many people as they can in these planes and go from there. It's a very competitive space. So, there's all these kind of opportunities to buy good deals, and, maybe you want to fly to Beijing, and then there's an ad. It's like, oh, $70 flights, and then you click it, and, well, guess what? It's sold out. It's unfortunate. So then you go look on, Skyscanner or one of those other products, and it turns out none of the flights are even close to the price that was advertised on this ad banner, which is kind of curious, given that, they were just advertising this. So airfares have kind of only been going up in prices, and I always miss these deals. I don't know about all of you. It's kind of strange. So why is this happening? Well, this guy the new highwaymen of today, they're no longer kind of, I guess, playing with our credit cards that they buy off the dark web. Well, they're still doing that as well. But they also now work for pretty major companies, such as competitive airlines and airfare aggregators, who have some interesting approaches to business where, say I'm an airline and I sell my seats for $600, and a competitive airline has seats on that same flight and they're available for $300. Well, of course, everyone's going to go buy the cheaper flights, which impacts my business, and that's not something I want. So I hire old mate here to go and write some software that basically limits the ability for people to actually buy those seats. So suddenly those $300 seats, they are no longer available, which is quite a problem. So we have an example of a company we were working with called Hong Kong Express. And they had an issue where their seats were vanishing, right? So this is an actual airline. They have pretty serious costs. And they had this problem where all of the seats were getting blocked up and reserved, but then they were not transacting. And this is a core function of how they sell seats. They basically hold the transaction while you complete the process. So what was happening was bots were effectively being used by competitors to go through the process of booking a seat and then just holding it. And then that means, okay, so now we as humans, when we want to buy a seat, we have to go and buy the competitive seat because the cheaper seats are no longer available, unfortunately for us. The process is pretty simple, really. So effectively, the bot goes through the process of checkout, just like we would. It goes to the end. There's a few ways they can do it to block the seat. So either they can use a credit card that will eventually bounce. So it doesn't even have to be a valid credit card. Or they can use something like a PayPal type option or a payment redirection method. There's a range of different options. And what it does, as we've all used them, you go to use it, it takes you off the website to finish the transaction on PayPal.com, and then it redirects you back to the website to say, look, yep, we finished the transaction. But of course, they're not completing the transactions, they're just doing this. And then they're doing this in huge volumes, to the point where there's over 100,000 of these operating every minute, bots just going through this process and reserving these seats. They do this on both web, they do this on mobile, they do it in a whole different ways, and they're doing it in a pretty sophisticated fashion. So these bots have been able to kind of bypass typical bot mitigation techniques, bypass other bot defenses, and it kind of got to the situation where the airline actually couldn't pin down or block the attacker. So what was happening was, and effectively, if you go to the website when this attack is ongoing, you'll search, and nothing will be available for like 7 days in advance, or in some cases, weeks in advance. So they'll actually not just block out the seats on one day, or one time, or one air flight. They'll actually do it to every flight, on every day, on every single time, and all of this is happening in parallel, right? So they just had a bot that's just able to do this across the entire website and just completely eliminate the airline from how to sell things. Quite problematic. So how did they do this? IPs, WAFs can block by an IP address. This is a pretty common technique. This might work for kind of basic attacks where someone's just attacking from a certain country or a certain block of IP addresses. It's actually pretty easy to get around IP mitigation stuff. I think most of us would be pretty familiar with that. Every request being made from these attackers was through a proxy that effectively had an unlimited number of IPs. Every single request was a unique IP address. They never reused an IP address at all during the attack. So hundreds to millions of IPs. You can actually buy IP addresses and pay for it in gigabytes as opposed to paying for it by the number of IPs. So there's like websites you can just go to, illuminati.io, they sell them readily available. So there's huge businesses around this. We actually ended up tracing back a bunch of their IP addresses to IoT devices. So this is probably familiar with the Mirai botnet, which happened a couple of years ago, where effectively what someone figured out was if we take the 60 most common passwords for the default credentials, it's like admin password or password or admin, you can actually take over IoT devices like Philips light bulbs that people have in their house so they can change the lights when they're at work. This is the kind of problems with the IoT space. So we found out that light bulbs were quite literally attacking this website, which was interesting as a concept. But that's what was happening. The next thing they could do is, okay, so let's say we can't block them by IP. Sure, let's block them by something else. Let's use fingerprinting techniques, right? So fingerprinting is quite well known now. There's a lot of open source libraries you can use to detect by fingerprint. And this is what a typical fingerprint looks like. So it's made up of things like user agent, which is typically not used too often because the bot will obviously change its user agent quite frequently. But then there's all these other things that people assume, well, maybe don't assume, but utilize far more than they should. Things like time zone, the number of plugins the browser has installed, like is there plugins? Therefore, is this a bot? Does it have plugins equal 0? The language, the country, the fonts that are installed, so they'll keep a hash of all your fonts and they use that to track you. You can create a pretty good fingerprint hash, but you can also easily change that hash by just manipulating any/all of these values. Like your screen resolution. Are you iPhone and do you have touch support? Right? And if you have touch support, how many touch IDs do you support? Is it 10? If it's not 10, then you're not an iPhone, because every iPhone supports 10. And then there's things like WebGL support, audio support, all these kind of things, right? So of course the bot was getting around these detections as well by simply going in and overriding what the browser said it had. So there's a few ways you can do this. Chromium nowadays is probably the most popular way to do it, which is effectively just Chrome. You can run it completely headless now, and it can run JavaScript, entirely runs JavaScript like a real Chrome browser, which is, of course, the majority of the internet's usage. And then you compare it with something like Selenium or a few other tools, and you can use that to overwrite the default behavior of what Chromium looks like. So if you start trying to fingerprint the Chromium headless browser, they can actually start injecting JavaScript that overwrites the things you're looking to fingerprint. Like, does it have WebDriver equals true? We can quite easily get around that by injecting a prototype of the function that returns that value before it even starts running the code. We actually found in some cases that people were just custom compiling their own versions of browsers, because Chromium is open source, and would actually just eliminate the telltales that were actually built into it. So that makes it very difficult to even tell it's anything but a real legitimate Chrome browser. And then, there was a Hacker News thread, of course, where someone said, and this was quite popular on Hacker News, this is quite recently too, where they could detect headless Chrome because the user agent was headless Chrome. Well, of course, we know we can change that. Did it have WebDriver? True. Well, of course, we can set that to false. .Chrome apparently only exists in legitimate versions of Chrome. And of course, we can set that to true. In this case, I believe it actually is expecting just a string. But even if it's an object, we can actually enumerate and add in values to it. Permissions, all of these kind of examples. And again, plugins equals 0. And then, of course, there was an article that said, look, yep, OK, great. So we can change that by doing Selenium change headless, change the head, right? So now we no longer have headless in the user agent. And then we can, fix the languages and plug an issue by just simply going through and defining the concept of languages and set the language to whatever we want it to be. And then likewise, the same thing with plugins. So suddenly now, this headless browser is returning values that only a legitimate browser should be able to return. So that apparently fooled that problem. So effectively, they can get around detection techniques as well. And there's, Phantom.js is kind of an older browser, automated browser, which has a lot of other issues. Chromium, I think, is significantly better for attacking because it looks like real Chrome. It doesn't have all the quirks of what Phantom.js does, which runs errors incorrectly and all kinds of stuff. We've even actually found an attacker that just used a Chrome plugin. So you can actually download plugins from the Chrome App Store that actually scrape websites, and they can actually use proxies so that they get around like IP checks, but they'll run it and manipulate your browser just using a Chrome plugin that you can just download. So there's like web scraping plugins. They download LinkedIn lists. Apparently Google's okay with that. Other techniques, so we found that they were kind of simulating the entire user experience of someone that would actually go through and buy a ticket, buy a seat rather. And this meant that effectively they had a JavaScript running bot that would go through the process of actually entering text so that it appeared to be human. And then it would click search, it would wait, and then it would get the next page, and it would fill out the information, and then it would wait, get to the next page. And it did all this to avoid what is effectively biometric detection. It's like, oh, it's browsing too quickly, so we can stop it based on that. You can also, of course, randomize and fool these systems pretty easily as well. And in other cases, we've seen the ability to bypass native app device checks. So Google now provides a library called SafetyNet, which allows you to verify if a device is actually real or not. Again, Android is open source, so what people did was they wrote their own versions of Android that said true to that check, but in fact were emulations. And then, of course, the other topic is CAPTCHA, right? So, we work in the CAPTCHA space, and we've kind of been looking at other players in this space that we're probably familiar with. ReCAPTCHA, I would say, is probably the most used bot defense technology in existence, probably by far. It's used by blogs, websites. It's free, that helps. It's typically what people turn to for kind of mitigation. The first iteration of ReCAPTCHA, as we all love, is these text solutions, where what they were doing was, one of the words was a security word, which they were generating server-side, which is that one with a black dot behind it. And the other word was coming actually from a book or a newspaper or something, and people were helping them transcribe information, which is a cool idea, very googly. Problem is, this is a very commercial problem. There's huge commercial value in being able to take, photo of text, convert it to metadata. So of course, what happened was software called optical character recognition came out, and very big companies, including Google himself, invested a huge amount of money in improving that quality of that software to the point where Google actually came out a few years ago and said they can now solve their hardest versions of ReCAPTCHA with 99.5% accuracy, which of course not even humans are even close to. We were actually told by a major ticketing company that the first attempt of these ReCAPTCHAs, 35% of people got wrong. I mean, this is a big, big ticketing platform, right? So they gave up on that, they threw it out, and they came out with the I'm not a robot, this checkbox solution. So what they did here, and there was a white paper at Black Hat a couple of years ago that actually explained how these techniques work. And to get the checkbox, they actually moved from recaptcha.net to google.com on the API. So now they're on the root google.com domain space. And they did that so they could get access to the first-party cookies on google.com. So effectively, what it turned out was that if you don't have a cookie, you get a challenge because you're not a human, apparently. If you do have a cookie, they check a few things. Primarily, they check one thing, which is the age of that cookie. So if that cookie is less than 9 days old, you'll still get a challenge. But if the cookie is greater than 9 days old, they'll start giving you no challenges. There was actually, in the paper, they spun up 150,000 bots that went to google.com, grabbed a cookie, and waited 9 days, and they let them all through, even if they changed the IP address and user agent from the origin of when that cookie came out. There's, so Cloudflare quite famously use this against people using Tor browser. I'm sure some of us have used Tor browser and have come across this situation. There's a plugin for Tor browser called CloudHole, which swaps google.com cookies between people so that they can basically brute force and get around having to solve the visual challenge. But more interestingly is the challenge itself. So once again, Google kind of came about this from the approach of how do we get people to help us do something at massive scale that's really valuable to us, but we can potentially use for a security challenge. So, I mean, we've all seen them. So in this case, it's select all the images with pickup trucks. Maybe you've seen street sign versions. But again, this is a commercial problem, right? So there's readily available software and huge companies working on the concept of how do we take a photo and figure out from that photo what's the information inside it. Like if you upload an image to Facebook, I think less of us are doing that nowadays. But if you upload an image to Facebook and say the Eiffel Tower's in the background, it knows you're at the Eiffel Tower without even you having to associate location data. That same software can be used to completely bypass ReCAPTCHA because, of course, they're just photos. So we used Amazon Recognition for this example, where you can just scrape the photos, base64 encode them, send them to the API. It returns to you a list of labels in a nice JSON formatted formation, and you can get through it. There's also, of course, the more nefarious people on the internet who are, commercializing the concept of bypassing this technology. So there's a product called XEvil. It's a Russian piece of software, of course, that breaks CAPTCHAs. So it's a spammer tool. It's $400. It's not too much. It can solve arithmetic, which is great. I struggle with that. Noise, unlimited noise, whatever that means. Fonts, unlimited. That's great. Awesome. And it is backed by the most state-of-the-art neural networks. Interesting. So what does this mean? So we got this software, and we pointed it at reCAPTCHA, and we spun up a whole bunch of instances, and it doesn't connect to the internet at all. So this is just it's a piece of software that runs locally. So there's no like call outs to like, humans solving sweatshops or any of that sort of stuff, which is another thing. And what it effectively does is it has a pre-trained library of what all the different questions reCAPTCHA challenges you with. And it can just go through and solve them completely offline, completely unassisted. And this is only $400. And it has a greater than 95% solve rate from what we found. They advertised 90 to 100%, so that seemed about correct. Which this probably should give you some good examples as to why, of course, bots can get around this technology as well. That's enough of that. All right, moving on. So, and then, of course, we're all kind of familiar with the high level of each of these things. People have done entire talks dedicated to each of those topics. I'm just giving a high-level example. We've heard about this concept of someone taking inventory from a website using software, probably in different verticals more often than airfares, right? So the ticketing space is quite famous for this problem, where people are using bots to buy tickets and then resell them on third-party websites. We were actually told by a major ticketing reselling company, sorry, not a reselling, a first-party ticketing company, that if they eliminated bots, it would go from 3 minutes to selling out to 6 hours if it was just humans buying those tickets. So it's crazy, right? I mean, that's how fast bots are basically just getting in there and doing it. And so why are they doing that? Well, because they can make quite a lot of money by marking up the prices, right? There's, once again, readily available software that you can go and buy. $900, this one. $990. It's a bit more expensive than the CAPTCHA solving service, but it also has CAPTCHA capabilities built in, so maybe that's why. But effectively what you do is you tell it what tickets you want to buy and from which vendor you would like to purchase them from. They support all the major leading platforms. And they have great support, I've been told as well. But effectively, they then go through, and it looks terrible. It's ugly software, but it works. And it does effectively the same techniques. So it goes through and emulates what a real human should do. And you can spin up as many of these as you want. You can even buy it so that they self-host it on their infrastructure. So you can just pay for like infrastructure as opposed to buying the software directly. Some interesting business models. And then there's a whole bunch of other different use cases that we also know about, right? So e-commerce. I don't know if you tried to buy the NES or the SNES at some point recently. That was also bought out entirely by bots. Thanks. Shoes. Yep, we'll talk about that in a second. And gift cards are interesting as well. So I found this script on Pastebin, the best place to find vulnerabilities. And it's very sophisticated. This actually works on a leading retail website. I won't say who. And effectively, all it does is it literally brute forces their gift card, like check balance process. It's very simple, right? I mean, that's all it does. Of course, this is powered by a bot that does all those other things, right? So it skips fingerprints, has unique IPs. But then they've just got this at the front, and it's just brute forcing the checking of, and it takes a long time, granted, but if you can get one, you get $500, $50, $100. And typically what retailers do is they have the cards when they're sitting on the shelf, they're not activated. So that's why you have to activate them. When they're activated, and until someone spends it, you can actually check the gift balance. And if it comes back saying, yes, there's a gift balance, well, guess what? You've got a valid gift card, and you can use that to go buy something. So that's a problem. Sneaker bots. So there's a video for this. I don't think I have audio. I don't know if I want to play the audio. But there's a bot, and they made a video to demonstrate how it works. And it's actually, I don't know if we can, yeah. So it's actually Kanye West who made this software, apparently. And he helps the hacker in the hoodie to go on his journey of buying shoes. Problem is, there's this innocent child who's going and lining up, as we all do, and he can never buy the shoes. It's really upsetting. So the kid then tries to, try and hack the. It's very violent too. Sorry. He then tries to hack the website by using multiple computers at once. I'm sure we've all done this with tickets when we try and buy them, right? It's like, oh, that's not working either. The inventory's sold out. Oh no, forbidden. And Kanye West comes to save the day, which is great. And there's a piece of software. Oh, this is too long. Anyway, eventually the moral of the story is if you cheat, you can get the shoes. This is the software here. They so don't pay inflated resale prices. Guess what all their customers do with the software? They buy shoes and then resell them. That's fine though. They don't have any issues with this. They even have a term for it. It's called copying, apparently. They learn so much. 10,000 testimonials. There's all kinds of cool stuff you can find on the internet. They actually have an estimation of the resale value of their shoes because they know the markup price, even though they're saying, oh, you don't have to worry about that. You won't get resold shoes. You can afford the legit ones because you use our software and it bypasses all these different websites like Nike, Adidas, etc. Right? And as you can see, this one person who couldn't get his one pair of shoes at the store ended up buying, like 12 or whatever. So he then can resell them for, instead of $200, try 1,000, right? So there's huge markups they make on these because they're limited edition and everyone goes nuts. This software is only $325, so that's actually a pretty good investment. They have 45 specialists constantly updating this software. It's a lot of people that you have to somehow figure out how to write software that they can't reverse engineer, which is significantly easier than writing said software to block them, right? So that's a problem. It's a problem. Pokemon Go, we're all familiar with Pokemon Go, I think. This game, by design, is actually super flawed to stop cheaters because it actually trusts client-side information. And obviously, as we've learned earlier today, doing that is a bad thing. They trust GPS data coming from the end user. They trust where the user's clicking and interacting with the UI. A typical game like an MMO, all of that information was all done server-side. But in the case of Pokemon Go, they decided we'll trust the client, what could go wrong. The first person to level 40 was a bot, so that's great. There's a pretty big subreddit called Pokemon Go Dev, I think, where they're effectively just going through and figuring out every time they release a patch how to reverse engineer the patch so their bots can still work. The most popular repo that I could find had 300 plus contributors that were helping them improve the software, aka break Pokemon Go. And I think a big issue as to why people gave up is because they couldn't win in the gym battles. Because, well, guess what? All the people that are won in the gyms are bots that are playing like 24/7 around the clock, and they're just high level, better items, blah, blah, blah. We actually found this was actually quite interesting. So the attackers here are so motivated because we're gamers. Gamers are motivated people, less nefarious than buying shoes and tickets maybe. That they actually were the ones where we found they were bypassing safety net by writing their own versions of Android so that it basically looked like it was real Android. And, well, no, it wasn't. It was a bot. Because Google came out and said, look, we've solved this problem. We can check every phone. We can confirm if an Android phone is a real phone or an emulated piece of software. And if it's a real phone, of course, you can't really scale very effectively to write software on it. But that was within a month broken. And then one other topic I wanted to bring up, which kind of creeped me out, was people using the deceased registry. You can actually get access to it. I think it's called master death file or something. I don't know, there's kind of a weird name for it. It's actually a government thing that everyone that has a social security number, which is most Americans, I don't, thankfully. I'm not American, so I'm safe. Everyone that dies actually is listed in that record. And it was actually leaked a couple of years ago. So there was a leaked list of everyone that's dead, which is a bit morbid. And the other way you can get access to the information is if you know people's social security numbers. That'd be interesting if that information ever leaked. Equifax. So someone on Twitter posted about the net neutrality issue that happened. And effectively, they found out their mother, who died a few years ago, should have been 71, she made a few comments pro-net neutrality, which is interesting considering she was dead. So what they were doing is they were actually scraping the list of the deceased, and then they were using that list to then write software that would then go and write and comment and positively in favor of net neutrality in all the different states. So that's probably something that people haven't heard about much, but that happens as well. And then, there's a whole range of other more commonly known situations like account takeovers. We all know about that. Fake accounts, fake ratings. perspective. In the case of a ticketing website or a retailer who's selling shoes, they're not really that motivated to stop the attackers because they still make their money. There's actually quite a lot of government legislation that's now coming in and starting to mandate that they put a bit of effort into it. And then the other thing is, if you have bots creating accounts, if you're a big website, and your shareholders are like, well, your growth is great. Well, guess what? That growth is probably largely bots. In a lot of cases, it's a lot. So if they suddenly stop the bots, well, that growth number is going to go down. That's not going to look good. So there's some weird conflicts of interest on the defender side in some cases. Other cases, it's very clear. If you're an airline or gift cards where it's actual fraud and you're losing out on that, they're very motivated to put effort into preventing that. And of course, how do we solve these problems if it's impossible to? Well, you focus instead on assuming you can verify that it's a human or not. Focus on things that the bot can't get around or can't fake. Like limiting things like payment redirection options, or don't give them a timeout in some cases under high volumes of attacks. You could perhaps do it by a user account ID, something that they have to log into and create. Maybe it has to be linked to a credit card or something like that instead. Obviously, a PayPal ID would make more sense. So each user email has a list of, and of course you can buy them on the dark web too. So yeah, it's kind of questionable how well that's going to work at scale. Limiting by concurrent sessions by IP. I mean, it can work if the attack is basic and simplistic. It'll be effective, but if it's a major, sophisticated attack, not so much. And then the other thing you can do is design systems to be anti-friendly to bots. So I think something like Snapchat is a good example where you can't really use a bot to go in and do much damage. You can't chat to other people unless you add them, and then they have to accept you. It's kind of designed to be something that doesn't really work very effectively for a bot, unlike something like AIM, which you could just spam anyone you wanted, which of course was then a huge target for bots. And then everyone left AIM because you'd have an account and you just get spammed. So that is the end of my topic. Happy to answer any questions. Also, we brought Tim Tams from Australia, so I'd highly recommend you have one. They're not a biscuit, and they're not a cookie. They're kind of like a wafer thing, Kit Kat maybe. It's kind of hard to describe because we don't have the term biscuit. We call them scones in Australia. It's very confusing. And we also brought Vegemite, but that's anyone have any questions? Of course it's illegal, but you can't determine who's attacking you, right? If they do their job correctly, it's impossible to trace back. We see the issue largely in the Asian region more than the US region. Richard Branson at one point mentioned that some of his competitors were doing things in line of what I described as well. So we know it happens in like the UK, but what can you do? If you can't find the attacker, I mean, that would be great, but like, ticketing websites aren't shutting down ticketing attacks because guess what? They can't sue people that they don't know who really is doing the attacks. This is a fair comment, but I don't work at Google, so no, unfortunately, I don't know. Yep. I'm sure there's alternatives out there if you search there. Yep. We can talk about that after, if you would like. Any other questions? Nope. Okay. All right. Thanks, everyone.